let's review some trig using this information. We know the cos of some angle A is 3/4, and that angle is somewhere between 270 and 360 degrees. And that means when we start in standard position, we are going to rotate 90, 180, 270, and land somewhere between 270 and 360. So here is my reference angle between that terminal side and the x-axis. And now I can draw in a right triangle. And knowing that cos is adjacent over hypotenuse, I can label on my triangle my adjacent side is 3, my hypotenuse is 4. Doing Pythagorean theorem, 4 squared minus 3 squared will give me radical 7. And this side of the triangle should be negative because we are going down into the fourth quadrant, which will make all of our other trig functions besides cos and secant be negative, because in the fourth quadrant only cos and secant are positive. All the other ones will be negative. So my other trig functions, secant, the reciprocal of cos, is just going to be 4/3. That's an easy one. And then sine of angle A is going to be the opposite over the hypotenuse. The cusc, or the cosecant of angle A, is the reciprocal of sine, which when we rationalize the denominator will be -4 radical 7 over 7. And the last two trig functions, tan of angle A, opposite over adjacent, and cot, and rationalizing that denominator gets me -3 radical 7 over 7. Let's come back to the beginning now. Since we know that cos A is 3/4, we can actually use our calculator to figure out the angle by doing inverse cos, or arc cos, of 3/4. And we get 41.40962211 degrees. If I want that in degrees, minutes, and seconds, I'm going to go second apps, number 4. And it would be 41 degrees, 24 minutes, 34.64 seconds. I'm going to use the 41.4 degrees as our reference angle. So to land at that spot, I either could have went negative 41.4 degrees, or I could have gotten 360 minus 41.4, and that would land me in that same location, which is 318.6. So 318.6 and negative 41.4 are coterminal angles. And 41.4 would be the reference angle for a 318.6 degree rotation. Knowing your unit circle is a huge help doing trig. So we already talked about in the first quadrant, all trig functions are positive. In the second, only sin and cusc are positive. In the third, tan and cot. And in the fourth, cos and sec are positive. Now I've also on my unit circle labeled my multiples of 90 degree rotations. 1, 0, 0, 1 at 90, -1, 0 at 180, 0, -1 at 270. And recall that every single point there is the cos of the angle of rotation, comma, the sine of the angle of rotation. So for example, at 180 degrees, cos of 180 is the first number, -1. And the sin of 180 is the second number, 0. And tan is equal to sine divided by cos. So if I'm at 180 degrees and want the tan of 180, I'm going to do the sine divided by the cos, and 0 divided by -1 is 0. And remember that at 90 and 270, tan will be undefined because you cannot divide by 0. The coses are 0 at those two locations. Now let's do our special reference angles, 30, 45, and 60. 45 is an easy one to remember. That's radical 2 over 2 is the cos, and radical 2 over 2 is the sine. Now at 30 degrees, I always remember that the sin of 30 is a half, which means my cos has to be the radical 3 over 2 number. And then 60 degrees is just the flip-flop of that. Cos of 60 is 1/2, and sin of 60 is radical 3 over 2. And notice here, depending on where you start from, if I start at 60, I can count 1, 2, 3 for my numerator, 1, 2, 3 back up for my numerator. And by knowing those, then I can go and say, okay, if I rotate 240 degrees, 180 and 60 more will land me into the third quadrant. At 240 degrees, my reference angle is 60, so if I want to know the cos of 240, it's going to be the cos of 60, but negative, because we're in the third quadrant where only tan is positive. If I want the sin of 240, it's going to be the same as the sin of 60, radical 3 over 2, but negative again. And then my tan of 240 will be sin divided by cos, so negative radical 3 over 2 over negative 1/2. The denominators cancel out, the two negatives cancel out, and that leaves me my tan to be positive radical 3. Let's continue using that 240 degrees. Let's say I want to know how many radians that is. Well, you have to know that there is pi radians in 180 degrees, so I can just make a proportion. And I'll cross multiply. If I want to leave this in terms of pi, I'll just divide by 180 and reduce this down. The zeros will cancel out. 6 goes into 24 4 times. 6 goes into 18 3 times. So 240 degrees is 4 pi over 3 radians. Or on my calculator, I will get 4.188790205 radians.